take a radical of a negative number? Can I take a radical of negative 4? Can I have a negative inside my radical? No. That's where imaginary numbers comes in. So that's what we're going to talk about today. When you have a negative inside a radical, you can start to do something because we're going to introduce imaginary numbers. Okay? Not all quadratic equations have real number solutions, such as x squared equals negative 1. I would be taking the square root of negative 1. Okay? Here is a rule you have to memorize. If you have the square root of negative 1, that is always going to equal I. We're going to go through all of this. This I represents your imaginary unit. Okay? So here, you have an imaginary unit. The unit is I. I equals radical negative 1. Okay? Because now I'm going to start introducing imaginary numbers, which is a whole nother game that we're going to play here in math class. And within the imaginary unit, it's what allows us to represent solutions that don't have real number solutions, quadratic equations that don't have real number solutions. Okay? If you have I squared, it equals negative 1. This is important to know. It will help you out a lot. Okay? Which makes sense, because if I take the square root of I squared, I'm going to get I equals radical negative 1. Okay? So here are some rules we have to follow. The square root of a negative number. If R is a positive real number, then radical negative R equals I radical R. So what we're going to do is this. If I have the number radical negative 3, I want to get that negative out of there. Okay? I'm going to get that negative out of there by representing it with an I. So this becomes I radical 3. I'm taking my my radical and changing it so that I can do stuff with it. Okay? If I have radical negative 4, what do you think that becomes?
Radical 4.
Okay, what is radical 4? So my answer actually becomes 2I. I take the square root of that, and then I represent the negative with an I. Okay? So what would radical negative 25 equal?
5I.
5I.
I say 2.
Okay? So anytime there's a negative, you're representing it with an I.
Do I have to write my I like that?
No, but it's easier because you won't confuse it with a number later on.
So,
Yes.
any number that doesn't have a square root, you write it with the I, and it's negative, you write the I in front of the...
Yeah, in front of the radical. Correct. Okay. That also has another property that goes with it. Okay, by the property 1, it follows that I square root of R squared equals R. So what it's saying is this. If I have I radical 3 squared, okay, then I know that I have I squared, okay, because I would distribute it. I have I squared. Does that make sense? And then what is the radical 3 squared? What happens there? When I square a square root,
3.
it just becomes 3. That cancels. So I get this. Now, what does I squared represent? What number?
1.
Not 1.
Negative.
Negative 1. So I have I squared times 3, so I get negative 3. So anytime you see an I squared, you're going to change it to what number?
Negative 1.
Negative 1. Okay? Because I'm going to start to be able to get solutions because I can change that to a negative 1 and start to solve some things. Okay? Wait. Just let me go. I had it up like the whole time we were going over homework as well. Okay. 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 So let's solve some equations. Okay, let's start with 2x squared plus 11 minus equals negative 37. what would you do to start this equation? Subtract 11. Okay, when I subtract 11, I get 2x squared equals negative 48, yes? Now what would you do? Divide by 2. And then I would get x squared equals negative 24. Then what would you do? Take the square root. Now, I get x equals what?
The square root of 24.
What?
You do,
Square root of 24.
Well, does 24 reduce at all so that I can make a different radical?
I think it, yeah,
Yeah, 24 has 2 and 12, right?
an 8.
And 2 and 6, and
I have a question.
2 and 3, what?
Since 3 things in going to 24, doesn't matter what you do. Like I could, like if I
No, it
use
doesn't
A
matter,
3,
no, you'll come up with the same answer if you do it. Okay, so I have a group of 2's, yes? And then inside I'm going to leave a 6. So, you have to represent that negative. Remember that these answers have a positive and a negative solution always, because I'm taking a square root, that doesn't change. And then I'm going to have 2i radical 6. So what I did was, I took what I could outside of it, combined it with the I, and then left what stays inside it under the radical. So you have an answer of x equals plus or minus 2i radical 6.
So why'd you pick 2 and 6?
Why did I what?
Why'd you pick 2 and 6?
Because 2 is a pair, so I can take it out, but 6 has to stay in because I have to multiply those numbers back together because they're not a pair, I can't take them out.
I'm so confused.
We're gonna do more. How would I solve x squared equals negative radical 13? Take the square root, and you get what? X equals what?
Plus or
Yep,
minus
on radical what? 13, because there's nothing I can do with that. Beautiful. Okay, how do you solve x squared minus 8 equals negative 36? Add 8, what does that give us?
negative 28.
So x squared equals negative 28, what do I do?
X equals plus, we'll find the square root.
That word was going crazy. Okay, find the square root, and I get x equals what?
To the radical form.
2 radical 7? Because 4 times 7 is 28. So plus or minus 2 I radical 7.
I need to do them steps.
You what?
I need to write them steps.
Steps down? Okay.
Wait, so
Yes, Tyler.
I got that, but it's because instead of 4 and 7, I did 2 and 14 and then 14.
That's fine,
7
you
and
can do it that way
2.
too.
Is that how you do it?
Yep.
Oh.
Beautiful.
Are we splitting this lesson up?
I'm not sure. This lesson's really, the latter half is very easy. I'm gonna, it's graphing, it's very easy. You're gonna graph the rest of your life in this class. Yeah, we probably are splitting this up,
No, I never go with it. I never do
because you're not gonna want to rationalize the denominator yet with this.
Actually, that's a lie.
This is already a lot.
I go
Okay.
all the time.
So I'm taking out a negative by representing it with an I, with an imaginary number. That way I can solve everything else. Everything else is still the same as what we did yesterday. You literally just have to take an I out to represent the negative. Otherwise, you're reducing just like you did yesterday and doing a factor tree and coming up with what you can do. Same concept.
Who did that?
Okay, here we go. So, then you get something called the complex number system, okay? When you have complex numbers, that means I have a number plus an imaginary number, okay? So the way you write complex numbers is with an actual number and an imaginary number. That is also a coordinate for me, okay? You know how you have like an x and y axes and you have an x and a y and you can graph it? We're going to talk about how to graph imaginary numbers in a second. So a complex number is written in standard form. The standard form is the whole number plus the imaginary number, okay? Where a and b are real numbers. The number a is the real part of the complex number. It represents my real number. And then bi is the imaginary part of my number. okay? If b does not equal 0, then a plus bi is considered an imaginary number. That's an imaginary number. If a equals 0 and b does not equal 0, then a plus bi is a pure imaginary number. We're going to talk about what that looks like. Okay. These are just the rules. I always think doing things is easier. I didn't realize that was longer. Okay. So here's what I need you to see. Right here, sums and differences of complex numbers. We're going to talk about how to add these together. Very simple. It's like, I always tell everyone, pretend that it's an x, okay? Pretend the I is an x. So when you add numbers together, if I have something that says 4 plus 12x plus 6, what do you add together in that scenario? 4 plus 12x plus 6. You add 4 and 6 together. Why? Because they're the constants. They're the same thing, right? So I would get 10 plus 12x. I can't do anything with this because it's not got a like term. Same thing happens with imaginary numbers. When I'm adding imaginary numbers and constants, I can only add imaginary numbers to imaginary numbers. Okay? It's like having the same type of thing. So the sum of a complex number, if you have a plus bi plus c plus di, you add a and c together, you add bi and di together. You add your imaginary numbers together. Okay? It's like adding like terms. Nothing changes. Same with the difference. When you're subtracting like terms. I'm subtracting my constants, my a and my c. I'm subtracting my b and my d. Okay? So there's nothing really new there if you think of it that way. Okay? There's just an I instead of an X. Actually, I want to skip this for now. We'll come back to that. Okay. So here it says, write the expression as a complex number in standard form. Standard form means what comes first, the imaginary or the real number?
Real.
Real. So I'm going to write it with real, then imaginary. What do you think I would do to this? It says 4i parentheses negative 6 plus I.
Distribute.
Good. We're going to distribute. What is 4i times negative 6?
Negative 24i.
Negative 24i. What is 4i times I?
4i squared.
4i squared. Okay, now here's where this comes into play. When you see I squared, what do you know that is?
Negative.
Negative 1. So technically, I have negative 24i plus 4 times negative 1. What's 4 times negative 1?
Negative 4.
So if I wrote this in standard form, I'm going to write negative 4 minus 24i. And that's what they want when they ask you to write it in standard form. So when you're writing a complex number, anytime you get I squared, you're going to replace it with what? Negative 1. And it makes my life a lot easier. Okay? So if I multiply two i's together and I get I squared, I'm replacing it with negative 1. Okay?
What's the difference between writing it with the 4 in front or 4 in the back?
When the 4 is not in front, it's no longer in standard form. Because when I go, we're going to explain why in a minute. Or tomorrow. When I go to graph this, because I can graph this is a set of points, I need my whole number, my real number first, and then I need my imaginary number. Because you're going to change the x and y axes to xi. So I takes place of your y axes. Now you'll be fine. Okay, how would I solve this? 9 minus 2i times negative 4 plus 7i. FOIL. What's 9 times negative 4? What's 9 times 7i? 63i. What's negative 2i times negative 4? Positive 8i. What's negative 2i times 7i?
14i squared.
Negative 14i squared. Okay, now let's do some stuff. Let's simplify. I can combine like terms right here. What's 63 plus 8?
I squared.
No, just I, because when I'm adding, I don't square anything. Only when I multiply. What is I squared over here? Negative 1. So I have this. So now I have negative 36 plus 71i plus 14. What's negative 36 plus 14?
Negative 22.
Negative 22 plus 71i is my standard form.
Don't move.
I'm not moving.
I mean, like,
I know, we're gonna stop there anyhow. Yeah. But tomorrow we're gonna talk about complex conjugates.
Try to explain.
Complex what?
Conjugates.
Conjure what?
Conjugates.
It really be like that.